We've got a rod, which is this one here, PQ. Mass 10 kgs and length 6 metres. So even though they haven't written 6 metres on here, it goes 4 metres out to here, but the whole thing is 6 metres long. And it's got a length of it's got a mass. So in the past, sometimes these rods haven't had a mass, but it has a mass at 3 metres. So here's 4 metres up, here's about 3 metres here, and it has 10 kgs, which is 100 newtons. There's a mass of 20 kgs, which is 200 newtons, is hanging from here. And we've got this rod holding it there. Alright, and this is the situation. Right, which is the following is the torque about point P. So here's our centre of rotation. When it says about point P, they say there's our centre of rotation. So this is the thing that's going to be rotating, that can move up and down. It can either rotate down that way or rotate up this way. But it's not, because everything's in balance. Just due, what's following is the torque just due to the 20 kg mass. So just what's the torque due to the 20 kg mass? Well, because there's an angle, we've got FR sine theta. So what is the angle? We've got 60 degrees here. If that's 90, that has to be 30 degrees. Okay, because we've got 60 and 30 is 90, plus 90 is 180. There's 180 degrees in a triangle. Alright, we've got the force is 200 times the distance out from here to where it's hanging is 6 meters, times sine 30. And sine 30 is a half. 200. Now 6 times a half is times 3. And before I go to the answer, which is obviously going to be 600, what do you notice about this? This is F times R. If you were just looking at the 200 times the 3 meters. So we've got the 6 meters all the way up here, and the angle. When you times those together, it makes it as though it's just this distance out to here, to where it's a 90-degree angle. Hopefully that doesn't confuse you. You don't have to take that into account. I'd just stick with this one if it sounded like it was confusing, but just an interesting point for you to understand how these what happens when you use this angle here. Anyway, 600. Easy. Alright, the next one. Which of the following is the tension in the cable SR? So here's SR, so this is obviously pulling back as those guys are pulling down, so the whole thing doesn't move. So I'm just going to set up my torque equation around that point P. So there's the torques in the clockwise direction, and they're cancelled out by the torques in the anti-clockwise direction. So I've got my things that are trying to move it clockwise here, and they are the mass of the rod and the mass of the hanging thing, and there's two of them on angles, so we'll put the formulas in. FR sine theta, and another one, FR sine theta, and the anti-clockwise guy is this guy here, pulling it back anti-clockwise, so it cancels out those clockwise torques. And we've got angles, so I'm just going to put in the FR sine theta. Right, the first one we've already worked out. There's the 600. Plus this other guy here, my second one is 100 newtons. He's 3 meters up, because that's where we've put. He's 3 meters up because it's 10 kgs, and you always put the mass in the middle. So it's 3 meters up, 100 newtons times 3 times sine, and it's going to be the same angle as this one, so that must be 30 as well, 30 degrees. And that equals the force, which we're going to find out, that's the tension force, times the distance to the cable here to here is 4 meters, and the angle's 90. 4 times sine 90. So 600 plus 100 times 3 times sine 30 is 0.5 equals F times 4, and sine 90 is 1. So 600 plus times those together you get 150, and that equals 4 times F. 750 equals 4F, and you divide both sides by by 4, sorry, you get 187, which is closest to 190.